In this video, we learn lattice plane from Miller indices. The drawing of lattice plane from Miller indices. Here we will take an example for easy explanation of the drawing of lattice plane from Miller indices. See, here I am taking an example. Miller indices 1, 0, 0. The intercept on axis along OX axis is A by 1, along OY axis is B by 0, along OZ axis is C by 0. So here you getting A, here you getting infinity, here you getting infinity. So three intercept points you getting. One is the finite along OX axis. So whenever you get the one finite value, you have to keep in mind that intercept exists only on a line which is parallel to each other. So see here, we know how to select the origin. So here we selecting the origin. Here x is a positive, z is a positive, and y is a positive. A, B, C are the lattice constant along OX, OY, OZ. Here intercept is at this point, and this is the x-axis, and parallel to this axis is also parallel, and this axis is parallel to this axis, and this axis is also parallel to this axis. So these four parallel axes intercept at A. Now you join this point to this point, and this point to this point, this point to this point, and this point to this point, and get a plane. That is a lattice plane from Miller indices 1, 0, 0. Now we come on example number 2. Example number 2. See, the intercept along OX is a by -1, and along OY is a B by 0, and along C is a C by 0. So here you getting intercept along OX, OY, OZ. Along OX you getting -1, along OY you getting infinity, along OZ you are getting infinity. So here you also getting a single finite value. So you have to opt 4 intercept points along -OX axis. So this is -x, this is -x, this is -x, this one is the -x. So here we are selecting origin. Here we are selecting origin, and this is -x, this one is the -x, this one is the -x, and this one is the -x. So this point is the point of intercept, and that is A. This point is also point of intercept. This point is also point of intercept. This is also AA, and this point is also intercept. This is also -A. Now you join this point to this point with a line. Here you join this point to this point to this point, and this point to this point, and shadow it. You get the lattice plane from this Miller indices. Now example number 2. See, it's a example number 3. See, the Miller indices is 1, 1, 0. Intercept value along OX axis is a by 1, along OY axis is a B by 1, along OZ axis is a C by 0. So here we getting intercept A, B, and infinity. So here you get 2 intercept values are finite and one is a infinite. Then you have to use this equation x by a plus y by b equal to 1. This is the popular equation of a straight line where the x is intercept by a and y is intercept by b. So here your intercept a and b. So you have to select, this is the origin, and this point is the intercept along y-axis, and this is the intercept along x-axis. So this intercept value is A, and this intercept value is B. Here you have to draw 2 parallel plane. This is parallel plane number 1, and this is parallel plane number 2. So this is parallel plane, and this is parallel plane to each other. So this plane and this plane parallel to each other. And you already selected this is the origin. So here this is the origin, this is the origin, and intercept value is this. Here intercept value is a, and here this intercept value is a b. This intercept value is a b, and this intercept value is a. So here you get two parallel planes. Now concentrate here in this diagram. See, this is origin and this is also origin, and this makes one line, one intercept lines, and this makes one intercept lines. So this line and this line. Now you join it with here to here, and similarly join to here, you get this plane, that is lattice plane of Miller indices 1, 1, 0. Similarly, example number 4. Miller indices is a 1 bar 1 0. So intercept will be a by -1, b by 1, and c by 0. And here you get your x-axis is a negative, y-axis is a positive. So here you have to opt the origin here. You have to opt the origin here. This is a b plus and this is a minus a. So intercept values is this and this. So intercept point is this and this, you have to connect it, you get the line. See here. Here this is origin for this plane and this is origin for second plane. This and this are both parallel plane. Now the intercept point is this and intercept point is this. Intercept point is this for second plane and this. So you have to join this to this and join this to this, and you have to join this to this and this to this, and shadow it, you get a lattice plane from Miller indices 1 bar 1 0. Now example number 5. Example number 5. See, our Miller indices is a 2 bar 1 0 0. So here intercept will be a by -2, b by 1 and c by 0. So minus a by 2, b and infinity is the intercept values. See here, this point we will take as a origin. So the intercept value is this point minus a by 2 and this point b. So here we get these values here. See, this is one plane and this one is the second one plane. This one is the second one plane. So here this is a intercept minus a by 2. Here this is intercept minus a by 2 and here y and y. Here you have to join this to this point, this to this point, this to this point and this to this point with a line. So here you get a plane and that is a lattice plane of 2 bar 1 0. Now we start example number 6. Example number 6 having Miller indices. Example number 6 having Miller indices 2, 3, 1. So intercept will be a by 2, b by 3 and c by 1. So you get 3 intercept value is finite. So here we take origin for 3 dimension. So see here, this is origin we are selecting because here x positive, y positive and z positive. So here all positives. So this is the intercept of along x, this is the intercept along z and along this is the intercept along y. So this point to this point is a line of intercept. This point to this line of intercept. This point to this line of intercept. That line of intercept equation you know from the example number 3 and 4. See, so you have to join this line to this line to this line, you get a plane. For proper explanation, here we drawn a cell. So here this is the intercept along y, and this is the intercept along x, and this is the intercept along z. So join this point to this point, this point to this point, and this point to this point, shadow it, you get a plane that will be the lattice plane of 2 bar 3, sorry, 2 3 1 Miller indices. Here this is a interesting things and very important. Here your Miller indices is in example number 7, example number 7. Here you getting here we discussing the Miller indices is 2 bar, 3 bar, and 1 bar. It means the intercept will be the a by minus a by 2 minus c and minus b by 3. So here this will be the minus b by 3, here they will be the here minus a by 2, and here minus c. So all axes are negative. So this is z negative, this is y negative, this is x negative. So you have to select this point as a origin. So here we selecting in this diagram, we selecting this is an origin. So you have to join, this is the intercept point, this one is the intercept, and this one is the intercept point. You have to join here to here, here to here, here to here. You get a plane, and this will be the lattice plane. This lattice plane of the Miller indices 2 bar, 3 bar, and 1 bar. This way we have to learn the Miller indices. This way we will learn the formation of lattice plane from the Miller indices. Thank you very much.